Alright, second example. We want the equivalent resistance in between terminals A and B. So again, the first step is to look at the nodes in this problem. So here's going to be our first node. Here is our second node. Here is our third node. Now the reason why we did this is because now we can see that the 12, 4, 6, and 2 ohms are in parallel because they all share two nodes in common, the purple and the yellow node. So that combination is going to be 1 over 1/12 plus 1/4 plus 1 over 6 plus a half. This will be 1 ohm. So let's go ahead and redraw the circuit. Alright, so now let's go ahead and look at the nodes in the redrawn circuit. We have one node, our second node over here, and our third node on the right. Alright, so now we can see that the two 8 ohms are in parallel because they share the brown and the purple node in common. Note that the two 8 ohms are not in series because if you were to place some kind of source in between terminals A and B, like say a voltage source, if current was flowing this way, for example, it would split at this junction right here. So because a different current would flow through these two resistors, they're not going to be in series, but they are in parallel because they share two nodes in common. So let's go ahead and redraw that circuit. Okay, there we go. Now the 4 ohms can be obtained by doing either 8 times 8 over 8 plus 8, or by doing 1 over 1/8 plus 1/8, but both is going to be 4 ohms. Okay, so now our problem has been reduced to a much simpler circuit. Let's go ahead and use a different color here. So now the 1 and 4 ohms are in series. So RAB is just going to be 1 plus 4 or 5 ohms. And this would be your final answer. Alright, so hopefully that was helpful. I'll see you next time.